Okay. I will start with one formula. Everybody okay with that? What is that? Formula for a circle, equation for a circle. It's also the Pythagorean theorem. Now, if we work in the unit circle, how does this change? One. Everybody okay with that? On Friday, you decided that sine in the unit circle is the same as what value of the terminal point? Sine is the same as the y value, and cosine is the same as the x value. So notice how I could change this. I'm going to put a cosine in for x and a sine in for y. And I'm just going to switch them around because that's how we usually write it. Hey, look at that. Now I got a handy-dandy formula. This is the most fundamental trigonometric formula that you will learn. Sine squared plus cosine squared is 1. Use it for the remainder of the year. Good ACT piece right there. Well, what else did you learn about x and y? Okay. Y divided by x is the same as tangent. So tangent of theta is equal to y over x. Now, y is the same as sine. X is the same as cosine. So really, tangent of theta is the same thing as sine over cosine. Look how we're coming up with all these new formulas. Isn't it exciting? See, you guys wear camo today. It's like I can't really see. It's like trying to pick you out and just blending in. Okay. Now, I'm going to write down the same formula. Sine squared plus cosine squared is equal to 1. And I'm going to divide through by cosine squared. Is that a legal operation in mathematics to divide through by something? What's sine divided by cosine? Tangent. So sine squared divided by cosine squared is going to give tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared. What's 1 over cosine? What's the reciprocal of cosine? Secant. So 1 over cosine squared will give me secant squared. Look at your sheet right here. Sine is opposite over hypotenuse, or y over r. Cosine, adjacent over hypotenuse, x over it. Then look at tangent, opposite over adjacent, and it says sine over cosine. You see cosecant, 1 over sine, secant, 1 over cosine, cotangent, cosine over sine. Look at over here, Pythagorean identities. Pythagorean identities. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And if, instead of dividing through by cosine squared, I would divide through by sine squared, I would get the last one, which is 1 plus cotangent squared is equal to cosecant squared. So these are all formulas that we could generate. It's not like they just came out of nowhere. It's not like it's magic. We can derive these pretty easily. Good with that? Okay, then let me show you the last piece. It's really important. Somewhere in your notes, draw 4 quadrants. So I just divide up x and y, positive x, negative x, so on and so forth. Everybody agree with those coordinates, where they're positive, where they're negative? Okay, let's consider our trig functions. Sine is which value, x or y? So therefore, is sine positive or negative in the first quadrant? Positive. How about cosine? That's x, so it will be positive. Tangent is y divided by x. Will that be positive or negative? And if they are positive, then so are their reciprocals. Tangent is y divided by x, and if you take a positive divided by a positive, you'll get a positive. If they're both negative, then it will be positive as well. So tangent will be positive down here. You'll see it. You'll see it. Okay. All right. We move to the second quadrant. Is sine positive or negative in the second quadrant? Why? Because y is positive in the second quadrant. If it's positive, so is its reciprocal, which is cosecant. Now, how about cosine? Is cosine positive or negative? Why? Because x is negative. So cosine of theta is negative, and therefore so is its reciprocal. So I'll write the positive ones in blue, I'll write the negative ones in red. Tangent, positive or negative? Why? Positive divided by a negative is a negative. Are we okay with those positives and negatives? Okay. What about sine in the third quadrant? And so therefore is cosecant. How about cosine? Negative. How about tangent? How come? Because a negative divided by a negative is a positive. So is its reciprocal. Let's try to apply our learning and look at the fourth quadrant. Which two will be positive in the fourth? Cosine and secant. Why will cosine be positive in the fourth? Because x is positive. The others will all be negative. Agreed? This is extremely important to your success on today's assignment. You have to be able to identify quadrants in which each trig function is positive and negative. Furthermore, you're going to have to do it on the test. Now, this is how I actually think of it. If you ask me, is sine positive or negative in the second quadrant, what goes off in my brain is this. Sine is the y value, and y is positive when it's up. So it's going to be positive in the second quadrant. That's what I think of. If you ask me about tangent, I think of where they're the same, it's positive. Where they're not the same, it's negative. Now, many other people think of it differently, and that's fine. You choose whatever you want. Here's the other way that people think of it. This is even in your book. There's an old-fashioned saying called all students will take calculus. All students take calculus. Well, that means that they are all positive in the first quadrant. That means that sine and its reciprocal are positive in the second. That means tangent and its reciprocal are positive in the third. And cosine and its reciprocal are positive in the fourth. That's fine. I will tell you, I never learned that. I was teaching here my first time teaching trigonometry, or I was teaching calculus, and I was talking about this as we were doing it. And some students were like, well, yeah, all students take calculus. Well, that's not true. They're like, no, we were talking about, we're talking about the graphic organizers. I still know what you're talking about. Okay, actually, Jack's sister was in the class, so she can confirm it. She was a smart mathematician, by the way. Yes, still is. So anyway, my point is this, is that they had to teach me. So you don't have to know that in order to understand it. I always think of just X and Y values, and that's what goes through my head. Okay? You do what you want. Let's use all that information to do our problems. Flip in your notes to this section. We're going to skip example 2. We're going to move to example 3. And it says, find the value of the 6 trigonometric functions given the following information. Sine is -4/5, and t is in the third quadrant. That means that if I have the position of t, I'm traveling around a certain number of units till I get to the third quadrant. Okay, so that's t. You happen to know that sine of t is -4/5. When it says find all 6, what I do is I write down sine of t, cosine of t, tangent of t, cosecant of t, secant of t, and cotangent of t. You have this problem on your test. It'll be worth 6 points. This is the second type of problem that people most commonly get wrong. People love to try other things, voodoo math, and these type of problems. Now, what value can I write down already for this problem? I can write down -4/5. It tells me sine of t is equal to that. And therefore, what other value do I know as well? Cosecant, -5/4. So, for those of you who come test time don't know how to do the problem, and you decide to write down 3 famous letters, we will have a personal conference between me and you and your parents. And we'll be talking about your inability to write that down and take the reciprocal, right? Like that, there's no excuse for that, right? Can we all agree? I'm not going to get any IDKs. I'll just get all angry inside. I'll start with the red pen, and it'll just be bad. Good. Now, how do we get the other values? Well, what I can do is I can use my information that I was given with my formulas. Namely, I'm going to use this one. Sine squared of theta plus cosine squared of theta is equal to 1. Second mistake that people will make is they'll square -4/5. And they take out their calculator, which is probably the worst thing to do in this situation, but they'll take -4 divided by 5, and they will square it, and you can see that you get that. They're like, oh, let's convert it to a fraction. And so I'll hit math, and I'll go convert to a fraction. I get -4/25, which is entirely incorrect. Why? What are 2 things that are wrong with that? You can only square the 5. What else? Should be positive, because you square a negative, you get a positive. But people will undoubtedly write down -4/25. Don't do it. Go parentheses, -4/5, and square it. And now that you got that, you can then math convert to fraction, or you can just save yourself a whole lot of time and not use your calculator. And just square -4 and get 16, and square 5 and 25. Because I'm not making this stuff up. I'm just telling you all the things that happen over the course of years. And it just frustrates me to no end. Instead of 1, what should I write? 25/25, because you know you're going to have to find common denominators for your fractions. Subtract the 16/25 from each side. Square both sides. When you square root a squared with a variable, you must list the positive or the negative. The question is it positive 3/5 or negative 3/5? Well, which quadrant am I working in? Third. Is cosine positive or negative in the third quadrant? It is negative, so it's a -3/5. So therefore, what is secant? Oh, hey, look at that. Just one little formula, I'm able to come up with two more values. Now, the last one is really simple. Anybody know a formula I could use to figure out tangent? Sine divided by cosine. So I take negative 4 over 5 divided by negative 3 over 5. Multiplied by the reciprocal. And you get 4/3. And now remember that when you're checking your work, you're in the third quadrant. So you should be able to think to yourself, oh, well, tangent's positive in the third, so I should make sure I come up with a positive result. Otherwise, there's something wrong with my mathematics. So I have all 6 values. So what I'll give you on the test is this, which is this sheet, which is positive quadrants, sine, cosine, tangent, sine, tangent, cosine. That's the part you see. So that summarizes it all for you. Okay. All right, let's try next one, B. This one looks really challenging. Sine of t, cosine of t, tangent of t. Cosecant of t, secant of t, and cotangent. What should I write first? Before that, cosecant is -2. Woo! That means that sine is -1/2. Got myself 2 points. Yeah. Now I have no idea what I'm doing. Well, let's draw a picture. Okay. I guess I could use sine squared plus cosine squared as 1, but before that, I'm going to figure out which quadrant I'm working in, because this doesn't tell me which quadrant, does it? Well, tell me this. Is sine positive or negative? It's negative. Which quadrants is sine negative in? 3 and 4. Remember, sine is y, so wherever you're below the x-axis is where it's negative. I also know that cotangent is less than 0. What does it mean to be less than 0? Negative. So if cotangent is negative, which quadrants is cotangent negative in? Second and fourth. So which quadrant do those overlap? The fourth quadrant. What's that? So the fourth quadrant is where they overlap. So therefore, I know I'm working in quadrant number 4. And so in quadrant 4, I know that cosine and secant will be positive, and the others will be negative. So sometimes people get upset because on the test, a lot of times if you miss a negative on the test, they'll just take off a half a point. Well, in this case, I take off more than a half a point, because deciding the positive and negatives, there's a lot more to it, okay? So now I'm going to use my formula, sine squared plus cosine squared is equal to 1. Square sine. 1/4 plus cosine squared is equal to 4/4. Subtract 1/4, cosine squared is equal to. Now what? Square both sides, positive and negative. Cosine of theta is equal to plus or minus square root of 3 over dose. Stands for 2. So, it's positive. We already decided that. So therefore, secant is, 2 roots of 3/3. You take the reciprocal, and then you got to rationalize the denominator. Finally, tangent. I'm going to take sine and divide it by cosine. -1/2 divided by root of 3/2. How do I do that? Multiply by the and pause. Do you agree that the tangent of t is equal to -1/√3? Can I leave my answer like that? No, but I'm going to end up having to take the reciprocal to get cotangent, right? So let's take the reciprocal right now. What's the reciprocal of this? Negative root of 3. Yes. So the 2's will cancel. There we go. That's all right. Thank you for asking. We got negative 1/2. So the 2's will cancel. We have negative 2 over 2 roots of 3. Still the 2's cancel. Left with negative 1 over the root of 3. Okay. So if I flip, I'm sorry, now that's that answer. It goes here, but I have to rationalize the denominator. So I have to multiply top and bottom by. I get negative root of 3 over 3. And there are my 6. Okay, so we are going to do problem number 9 from your worksheet. We're going to do problem number 9 because it's a little bit more challenging than the others. But again, the reason why I've created this worksheet as opposed to your book assignment, I'm not satisfied to the level at which we've shown mastery on this content in previous years. I'm tired of grading tests and grading this problem wrong. I want this to be one of the highest scoring tests of the year because it is the fundamentals of trigonometry, meaning we use all of this material going forward. This is not a one-time event at all. Okay, so let's do it. Tangent is equal to negative 3, cosine is less than 0. What do I first write down? Tangent, negative 3, and sweet. I'm not a delinquent. I do not have to have a meeting after school with Mr. Gens and my parents. What makes this problem now different from the others? We don't have sine or, so you know what? I might have to choose a new formula. Fortunately, we have 3 to choose from. And I personally like this one. 1 plus tangent squared is equal to secant squared. U is any variable. That's correct. So in your notes, it says sine squared of u plus cosine squared of u is 1. U is just the substitution variable. Substitution in u, if you get the idea. So anyway. So I've got 1 plus what? 9er is equal to secant squared. So that's 10 is equal to secant squared. So secant of theta is equal to plus or minus the root of 10. Oh boy, don't know whether it's positive or negative. How am I going to figure that out? To make my little chart here. Tangent's negative. Where's tangent negative? 2 and 4. Cosine is less than 0. That means cosine is negative. Where's cosine negative? 2 and 3. So where's the overlap? 2. So I'm working the second quadrant. That means sine is positive. The others will be negative. So secant is negative root of 10. How do I get cosine? Reciprocal, 1 over the root of 10 or root of 10 over 10. Cool. Now, I will tell you guys that you could do sine over cosine is equal to tangent, but unless you're trying to find tangent, I caution you, I've seen a lot of people make mistakes in this scenario. You sure can. But the way I teach it, because fewer people make mistakes, is to now just set up sine squared plus cosine squared is 1. I have to square the square root of 10 over 10. Negative root of 10 over 10. What is the root of 10 squared? 10. What's 10 squared? 100. So you'll end up with 1/10. Is n equal to 10 over 10? subtract the 1/10. Sine squared of theta is equal to 9 over 10. Square both sides. Sine of theta is equal to plus or minus 3 over the root of 10. Are you okay with that? Okay, you have to rationalize the denominator, correct? But before we get rid of that, what should we do with it? Take the reciprocal so we can have cosecant. When we do that, we get 10 over 3. So now, when we rationalize the denominator here for sine, we get 3 roots of 10 over 10. Not very pretty numbers, but that's okay. Yes. No, but if you take the reciprocal of that, you get 10 over 3 roots of 10. And you'll multiply the top and bottom by the root of 10. And you'll get 10 roots of 10 over 3 times 10. And then you'll probably cancel off to get the root of 10 over 3. So I think you save time by noticing right away and less likely to make mistakes. Just depends on the problem. Depends on the problem. Your assignment is to work through this worksheet. Some of them will have radicals. Some will be rational numbers. You have plenty of work to do. Okay? I will get you a study guide probably tomorrow. Right now our test is Monday next week. Did I say Thursday? No. Did I? Oh, I'm sorry. Right now the test is Monday next week. Oh, converting between degrees and radians. We just might not have time for that.